Alright, yesterday we learned about the tangent and secant lines and how a secant line crosses through the circle 2 times and a tangent line only touches the circle 1 time. Today I'm going to teach you about some of the power theorems that use those kinds of lines. The first one is the chord-chord power theorem. So if two chords of a circle cross, like they are in this first picture, what we can say is that if we take x times y, the parts on the same chord, that will be equal to z times w, the parts on the other chord. Now the way that I remember this one in my brain, because you know how I always have to have a memory clue, is part times part equals part times part. The next one is the tangent-secant power theorem. This one uses a tangent line and a secant line hitting the circle, and what this one says is if we take the tangent part squared, in this picture it's t, that's equal to the adjacent part that's on the outside, the part of the secant line, times the whole thing. So again, my memory clue part here is to remember tangent squared equals the outside part, the adjacent outside part, times the whole thing. Okay, and then the last one is the secant-secant power theorem. This one uses two secant lines hitting the circle, and this one says that if we take the outside part of one of the secant lines times the whole thing, that's equal to the outside part of the other secant line times the whole thing. So again, my memory clue here is outside times whole equals outside times whole. Okay, now let's try some sample problems involving these new theorems. The first sample problem uses our chord-chord power theorem. It says that if we take part times part, it equals part times part. So on this problem, we're going to say 3 times x equals 6 times 2. 6 times 2 is 12, and then to solve for x, we can just divide by 3, so we would get that x equals 4. Not too tricky. The second one is our tangent-secant power theorem. That one says that if we take the tangent part squared, that's equal to the outside part times the whole thing. So first, we have to figure out the whole thing is 9 plus 3, which is 12. So x squared equals 3 times 12. 3 times 12 is 36. How do you solve when there's a square? You have to take the square root of both sides. So you're going to get x equals plus or minus 6. Now, do we care about the negative 6 here? No, because we can't have a negative distance. So our only answer is that x equals 6. Alright, the third problem uses our secant-secant power theorem, and this is the one that says if we take the outside part of one of the tangent lines, so this part here, the 8, times the whole thing, which 9 plus 8 is 17, that's equal to the outside part on the other one, the 7, times the whole thing, which they've already labeled for us as x. So then 8 times 17 is going to be 136 equals 7x. Just divide by 7 on both sides, and we get that x equals 19.43. Okay. For the last sample problem, we need to notice that PS is a tangent segment. So this is actually a tangent-secant problem. Now, in order to do this, we have to figure out what is the distance between P and S. Because it's negative 6 to get from P to the origin, that's a distance of 6, and 4 more to get to S, the whole distance there is going to be 10. So PS equals 10. Now for PR, we'd like to know that distance as well. We're going to have to use the distance formula. So remember that the distance formula says we take a giant square root and we subtract the x-coordinates, so 9 minus negative 6 squared, plus we subtract the y-coordinates, 20 minus 0 squared. Okay, 9 plus 6 is 15 squared. 20 minus 0 is 20 squared. So we're looking at the square root of 225 plus 400, which is the square root of 625, which equals 25. So now we know that PR, the whole thing, has a distance of 25. We would like to find PQ, so for that we're going to use our new tangent secant power theorem, and the equation we're going to set up is going to be the outside, or the tangent part squared, so 10 squared equals the outside part, which is x, times the whole thing, which we just found to be 25. So 100 equals 25x. We'll divide by 25, and we'll figure out that that outside part, PQ, equals 4. All right. So this is a basic synopsis of the power theorems. Go ahead and try your homework. They will use all 3 of these power theorems. Think about what you need to multiply and what equation you set up, and then how you would solve it. Good luck.